Hi, welcome back for another weekly update. This is group 9 with our 5th update. We'll be going over results and some of the other things we did for the project, as well as a Jira update and a final report update.
I'll be talking about the results that we came to. So I included a single graph for the motion response and then also the frequency so that we could look at an example. And then there are a bunch of different trials that we did with different parameters and things for the optimizations, but this is the example we chose to show what all of those look like. You can see the wheel motion is in green, and then the body motion is in blue on this, with the bump profile being in red. And so a couple different things we looked for were the number of oscillations and the amplitude of those oscillations. So those were some of the things we judged the different criteria on that we'll talk about in a minute. But this was with one of our cases for a 25 centimeter tall bump. So it was pretty much, we were looking at worst case scenario for the Baja Cars suspension in terms of what we would actually come into seeing on a course. And now you can go to the next slide, Casey. We also looked at both the positional response as well as the frequency. And so here's the Bode plots for those things. The greatest magnitude there for this response came in around 40 radians per second, so about 6 hertz is what the suspension came to. And this is our things are a combination of ideal as well as the experimental values. And so we weren't targeting a specific frequency with this, but we were observing what different changes did to the frequency. And it was pretty consistent around that 6 hertz mark. We did look at some interesting things happening when we approached that, especially with multiple oscillations or multiple bumps happening.
So next we'll be going over the stability of the system. So for our system, we use the Routh-Hurwitz method and this is the transfer function that we had generated in the MATLAB code, throwing it into the matrix and throwing the matrix and calculating it out according to table 10.5.3 in the text. Our system is stable.
So looking at a parametric study of this is a range of values for the damping coefficients. We played around with the different ones until we got the results we wanted.
And then for the optimization of the parameter, we looked at the, like Tristan was saying earlier, the number of oscillations after the bump was over. Basically what we were looking to do was minimize the number of oscillations after the bump without increasing the full body response amplitude during the bump. And then we also looked at the wheel and body oscillation size compared to the bump size. And essentially we just want the wheel and body oscillation to be smaller than the bump.
Then I will go over a quick update from Jira and from our overleaf report. So as you can see, here's our overall timeline. We're just about to finish up sprint 4, and then the whole project's due at the end of this coming week. So from that, you can see our board. So we did the parametric study. We did the stability analysis using the equations. We did optimization of parameters, or parameter being the damping coefficient. We're discussing the results now, and then after we finish this discussion of results, we'll be able to go in and finish our report and hopefully have that handed in as soon as possible. So that's the update on our timeline from Jira. As you just a quick look at overleaf, we got this document where we started this report and we got stuff going, and we still got quite a bit to go, as you can see by all the red. But yeah, it's going well, and we are on track to be done early this week.